Hi, today we are going to discuss about the topic called as stack under the concept collection in Java. The stack is one of the subclass of vector class. It implements the concept called as stack data structure that is lost in first out. The stack contains all the methods of the vector class. In addition to that, it also contains the methods like push method, peek method, pop method. So in order to push the element onto the stack, we can use the method push off. There are two forms of push method, and in order to access the top of the stack, then we can use pick method. And similarly, pop method, in order to access the top by removing the top of the stack, we can use the method pop off. As an example, so stack resides in util package. So public class name followed by main method and stack data type, and the stack is the object new stack off. And then in order to insert the element onto the stack, we can use the method push method, so that with the help of push method the elements can be added onto the stack. And the pop method will remove the top of the stack, so that here the top of the stack, that is the element which inserted last, will be the top of the stack. So garima will be the top of the stack, so garima will be popped off from the stack. And similarly, with the help of iterator, we can iterate the elements of the stack. We have to remember that the iterator won't access the element in last in first out order, but it accesses the element in the same order in which we inserted onto the stack. So that with the help of iterator, when we access the elements of the stack, the output will be Ayush, Garbit, Amit, and Ashish. Have a look on this program for a few seconds. This will be the output. So let us get into the next concept, that is queue interface. Here the queue interface is to implement the concept of queue data structure. That is, we can access the element, we can maintain the order, that is first in first out order. It can be defined as an order list that is used to hold the elements which are about to be processed. That is, order list in the sense the first in first out order is prevailed here. The various classes which can be implemented from the queue interface are priority queue, array DQ. So here DQ means the double-ended queue, so which implements the interface queue. So queue interface can be instantiated in two ways, that is interface queue followed by the object and a new priority queue of, that is the class constructor, or else we can give new array DQ of. So by these two ways it is possible to instantiate the interface queue. So let us have an example. Import java.util.priority queue. You can give import java.util.star also. So this is class name followed by main method, and then priority queue. This is class name integer priority queue, integer data type, and then numbers is an object, and new priority queue of. With the help of add method, we can perform the operation enqueue on the priority queue, so that the elements 750, 500, 900, and 100 are enqueued onto the priority queue. As it is the priority queue, the elements are inserted in some priority. So the elements are stored here in the ascending order, so that it will be 100, that is the 100, followed by 500, and then 750, and finally 900 will be there. So here with the help of remove method, we can remove, that is we can perform the dequeue operation on the priority queue. So when we are removing each and every element from the queue, with the help of println statement, we are going to print the elements. So the loop will be executed till the particular queue is becoming empty. So the 100 will be removed first, and which will be printed, and 500 will be removed next, and which will be printed, and 750 will be removed next, and it will be printed, and finally 900 will be removed, and which will be printed. So the next one is the DQ interface, that is double-ended queue. It extends the queue interface. We can remove and we can add the elements from both the side. DQ stands for double-ended queue, so that we can perform the operation at both the ends. It can be instantiated as a DQ followed by the object name equal to new array DQ of. Here array DQ is the implementation class of the DQ interface. So array DQ is the class that implements the DQ interface. It facilitates us to use the DQ. So we can add or delete the elements at both the ends. Array DQ is faster than array list and stack because it has no more capacity restrictions. So let us have an example. So it also resides in util package, and our user defined class followed by main method and DQ data type. Here DQ is the object name, new array DQ data type of, and with the help of add method we can insert the element, that is enqueue the element onto the double-ended queue. Gautam, Karan, and Ajay are enqueued onto the queue, and in order to traverse the element, we have seen with the help of iterator we can traverse the element, and also with the help of enumerator we can traverse the element, or else we can use the for each loop to traverse the element. For string str colon dq, first the Gautam will be pointed and passed to str. After that, in the next iteration, Karan will be passed to str, and in the final iteration, Ajay will be passed to str. So the output will be Gautam, Karan, and Ajay respectively. The next concept is set. Set is a one of the concept comes under collection. So the main thing we have to remember here is set does not contain duplicate elements. It does not allow you to add the duplicate element. But in case of array list, you can add the duplicate item in the array list, but in the set it is not possible. So it implements the concept of mathematical set abstraction. The set interface contains only the methods that are inherited from the collection, and here the interface adds the restriction that you cannot add the duplicate element onto the set. So it also has a stronger contract on providing hash code operations so that the set instances can be compared even their implementation types differ. So even though the implementation types differ, with the help of hash code operation, the set instances can be compared. In order to instantiate the set, set data type object name equal to new hash set of or linked hash set or tree set. These are all the implementation classes of the interface set. That is the hash set, linked hash set, and tree set are the implementation classes of the interface set. So the various methods. Similarly, we are having add method in order to add the object onto the collection. Clear method removes all the object from the collection. Contains of returns true if the particular object is present. Is empty is to check whether the particular collection is empty or not. Iterator of, with the help of iterator of, we can traverse the elements of the collection. In order to remove the particular element, we can use the remove method, and in order to find out the number of elements present in the collection, we can use the method size of. The first one is the hash set. The hash set class implements the set interface. It uses the hash table to store the element. So as hashing technique is used to store the element, it is possible to access the element in the order of 1. And also the hash set contains only unique item. As hashing is the technique used here, and hash table is the place in order to store the data elements. So the accessing, that is searching, will be more efficient, and it contains unique items. We have already seen that in the set interface the duplicate elements are prohibited. Let us have an example. Import java.util.star. It also resides in util package, and then our user defined class name followed by main method, and then hash set. String is the data type and set is the object name new hash set of. With the help of add method, we can add the element onto the set. Here Ravi, Vijay and Ravi Ajay are added onto the set. Here Ravi is added one more time. So let us see what happened because the set does not allow the duplication. Similarly, with the help of iterator, when we traverse the elements of the set, the output will be Vijay, Ravi and Ajay, which means that the new duplicate overrides the old one. That is, at first the Ravi will be there, and next Vijay, and as a third element, when we are adding a Ravi onto the set, that is hash set, the older Ravi will be removed. The newer duplicate overwrites the older one, but the position won't be changed. We have to remember that. And finally, Ajay will be added onto the set. So the output will be Vijay, Ravi, and Ajay. Have a look on this for a minute to have a clear cut idea. So let us get into the next concept, that is linked asset. It represents the linked list implementation of set interface. It extends the hashed class and implements the set interface. In general, we can say the combination of linked list and hashing on the set becomes linked hashed. Like hashed, it also contains, that is linked hashed also allows only the unique element, so that the duplication is prohibited. It maintains the insertion order and permits null elements. But in case of priority queue, the null elements are not permitted. Linked asset permits the null elements. So as an example, it also resides in util package and public class name, main method, linked asset set object, and with the help of add method we can add the elements Ravi, Vijay, Ravi, Ajay, and with the help of iterator we can iterate the elements of the set. Here also there are two Ravis, so we have to see what happened when the duplication is added onto the linked asset. So when we add the duplicate, the older one does not allow the newer, which means that at starting the Ravi will be there, followed by Vijay will be inserted, and when the third Ravi comes, it won't be inserted onto the set because it is the duplicate one. So at the third position, the Ajay will be inserted, which means that the linked asset does not allow the newer duplicate to take place. But in case of hashed, the newer duplicate overrides the older one. We have to remember this. Have a look on this for a few seconds to have a clear cut idea. The next concept is sorted set interface. It is an alternate of set interface. It provides ordering of the elements. As the name itself we can find it, the sorted set means that we can sort the elements of the set. The elements are arranged in ascending order. The sorted set interface provides the additional methods that inhibits the natural ordering of the elements. The sorted set can be instantiated as sorted set, data type, and set, this is the object name, equal to new tree set of, here tree set act as a constructor which is the implementation class of sorted set interface. Java tree set is the class that implements the set interface. By the name itself we can understand that the tree set means that it uses the tree to store the elements. Like hash set, linked hash set, tree set also contains only the unique element so that the duplication is not allowed here. The accessing and retrieval time of the tree set is quite fast as it uses the tree for storage. The elements in the tree set are stored in ascending order. As an example, again import java.util.star followed by user defined class name and then main method, tree set, data type, and set is the object equal to new tree set string of, here tree set is the constructor, and set dot add of. With the help of add method we can add the elements onto the set, that is tree set. So while adding the element they are stored in ascending order so that the Ravi will be stored first. After that when Vijay comes, Vijay will be stored next to Ravi, and when the third Ravi comes, as it is already available, the third Ravi won't get inserted onto the set. And as a fourth element, when Ajay comes, as it is preset, the elements are stored in sorted order. The Ajay will be stored in the first position, so that with the help of iterator, when we iterate the elements of the tree set, we will get the output as Ajay, in the next line Ravi, and in the next line Vijay respectively. Have a look on this for few seconds to have a better understanding. Next topic is the map. The map contains the values on the basis of key. That is, the map contains key and value. It contains key value pair. Each key and value pair is called as an entry. A map contains unique keys. That is, the value can be duplicated, but the keys should be unique. So in order to have an efficient search or update or delete the elements on the basis of key, the map concept is very much useful. So map contains two values, that is the first part, two parts. The first part is called as key and second part is called as value. That is key and value pair. This is the Java map hierarchy. Here map is the interface. From the map interface we are having the sub interface as sorted map, and from that we can implement the class tree map class from the sorted map interface, and from the map interface we can implement the hash map class, and from hash map class it can be possible to extend linked hash map class. Have a look on this diagram for a few seconds. A map does not allow the duplicate keys, we have already seen, but it is possible to have duplicate values. I repeat, a map does not allow duplicate keys, but it is possible to have duplicate values. Here the concept hash map, linked hash map, allow a null key and value, but tree map does not allow any null key or null value. That is, in tree map that is not possible for null, but in case of hash map and linked hash map it is possible to have null. A map cannot be traversed directly, so that we have to convert the map into set with the help of either key set method or entry set method. So the various classes hash map, linked hash map, and tree map. The hash map is the implementation of map class. It does not maintain any order. Linked hash map, it is the implementation of again map. It inherits the hash map class. It maintains the insertion order. Tree map is the implementation of map and shorted map. It maintains ascending order. As like as tree set, tree map also maintains the insertion order. That is, it maintains the ascending order. The insertion order means that here we have to say it maintains the ascending order. But linked hash map maintains the insertion order as it is. The hash map does not maintain any order. Hash map does not maintain any order. Linked hash map maintains insertion order. Tree map maintains ascending order. So the next one is map.entry interface. We have already seen that is a key and value pair is called as entry. Entry is the sub interface of map. So it can be accessed by map.entry name. It returns the collection view of the map, that is the elements of the particular class. It provides the methods like get key and get value, so that it is possible to get the value from the map, and also it is possible to get the element from the map. Let us have an example. So java.util and then user defined class and main method. Map contains key and value pair, so we have to give the two data types. For one is for key and another one is for value. So integer comma string, which means that key will be of integer type and value will be of string type. And map is the object name. New hash map of, we can implement the map interface by three ways. One is hash map, linked hash map, or tree map. Integer string of, that is key and value pair. So the put method is used to insert the key and value onto the map. So that put of key comma value you can give. And in order to traverse the map, we have already seen map.entry can be used. So map.entry, m is the object, map.entry set of, so that the map is converted into set. And with the help of print method, with the help of get key and get value, it is possible to access the key and value. So with the help of get key and get value, it is possible to access the key and value of the map respectively. So references, you can refer Java T Point, Java Tutorial Point, W3 Schools for the better understanding, for more understanding, for in-depth understanding of collection concept. Thank you.